Hello, my name is Alvarado, and today I will be explaining 24.57. I'm sure you know the question, so I won't read it to you, and there it is. So for part A, we have to find the equivalent capacitance of the network between points A and B. To do this, we start off with the sum of those C3 and C4 because those are in series at the innermost part of the circuit. So the sum of the value of C34 is equal to the value of C3 and C4, which are the same. C3 and C4 are the same as 4.2. So we add them up, and then we invert them, and we get 2.5 U farads. Now we have the circuit looks like this. We have one capacitor here, and then it turns into parallel, where we have another capacitor here, but another one here, and this second one here is now C34, not C3 and C4. We're simplifying the problem. So now to find the C234, which is this one plus this one, since they're in parallel, we add them linearly. So we have 2.1 plus 4.2 equals 6.3. Now we're left with a circuit that looks like this, where all these are capacitance, and this is now C234. So now to find CEQ, we add up 1, 2, 3, 4, and 5. 1, 2, 3, 4, or that should say it 2. 2, 3, 4 plus 5 equals 1 over 8 plus 4, which is what it says up there, plus 1 plus 3, what we got, plus 8 plus 4, what C5 is equal to. And then when we invert it, we get 2.5 U farads, which makes sense that since they're in parallel and series and all that mumbo jumbo, that a lot of the capacitance should go down. It shouldn't stay as high as the individual ones are. So now part B says calculate the charge of each capacitor and the potential difference across each. So the Q for 1 and 5 is going to be the same because it's at the start and at the finish. So we can just use EQ or CEQ to solve for that. So we plug in our CEQ, which is what we got over here, and times the voltage, and we get our value for Q1 and Q5. For Q2, however, we have to use the capacitance at Q2 divided by the capacitance at 234, because that is where this whole capacitance changes. And we have to multiply by E naught, 5.54 times 10 to the negative 4. We do that, we get 3.7 times 10 to the negative 4. Do the same thing for Q3, and we get 1.9 times 10 to the negative 6. Q3 and Q4 are the same, so I can just say that Q4 is the same. Because as we know, Q3 and Q4 are part of the same little series there. And now we move on to the voltages, and we get voltage 1 is equal to Q1 over C1, which is the 5.54, which we got earlier, divided by 8.4 times, which gives us the voltage. Then we get V2, which is equal to 3.7 times 10 to the negative 4, 87 volts. V3, and that was the Q of V divided by the C at that was the V at 3. This one is the Q at 3, and this one is the C at 3, and we get 43 volts. And the same thing for 4 and 1 and 5, 65 volts are the same, so I just said 5 is equal to 65 volts. My answer looks to be right, because you can't add them up all and get 220 volts because they're not all in series. But if we did do the math and we inverted those in parallel and added those that were in series just together, we should get 220 volts. Yeah, thank you for your time.